have started the vector calculus. Okay, so there was one problem that we did not complete. Okay, so this problem was there. Okay, so wait, is my screen visible?
Yes, sir.
Okay,
Yes, sir.
okay. So I think this was the problem that we were discussing in the last class, isn't it?
Yes, sir.
What happened? Wait. Okay, now is the screen visible? Okay, so it's visible. Okay.
Yes, sir.
Okay. Yes. So now we were discussing about the gradient. Now if you see the gradient of a scalar, that means when we have a scalar with us and we are increasing the scalar by stepping from one point to another point. Okay, that we have seen for the equipotential surface. So the maximum rate of increase, okay, that means the maximum space rate of increase of that particular scalar is called the gradient. Now the question was that a scalar was given. Now the gradient of the scalar was to be found out. Wait, someone has entered. Now the scalar is given, that is W, and you have to find out the gradient of a scalar. So that part we have already calculated. That means the first part of the question we have already covered. Now we were discussing the second part. So this is the solution to the first part, this one. Okay. Now the second part, in the second part it is told that we have the gradient with us. Okay, that means as far the first part is concerned, suppose there were two curves like this. Okay, so in the two curves, this one was having W1 and this is having W2. This entire contour, which is called contour, this path curve is called contour. Okay, C-O-N-T-O-U-R, contour. Now if you want to shift to W2, if you choose this path, then this is the shortest one. This path is dn. So hence,
Yes, sir.
Hence you will get the gradient. Okay, so you will get the gradient. Now the thing is, you are getting the gradient which is delta W. Okay, now it is told that you have to find out, okay, the second part of the question is you have to find out the derivative, direction derivative dW by dl. That means this gradient is nothing but the gradient which we have already calculated. It is already dW by dl, but it is dW by dn, where n is the shortest path. But in the second part of the question, it is told that yes, we have to find out dw by dn, but dl is not equals to dn. That means dl is somewhere over here. Suppose this path, this is dl, which is not the shortest path. Some path may be the longest one, but at least not the shortest one. Shortest one नहीं है, shortest से ज़्यादा बड़ा है, तो उसका निकालना है. तो कैसे निकाल लेंगे? So what is dl? First of all, you have to know, because dn we know. So what is dl? dl is a displacement, actually a direction vector. Okay, it is a displacement. So it in the Cartesian coordinate system it is 3 unit vector x plus 4 unit vector y plus 12 unit vector z. So you have to find dw by dl in the direction, but at a point, that means this length, ये length है dl, वो तो एक वेक्टर है, उसमें तो uncountable number of points है, but a point is given over here. Wait, a point is given on that particular dl. There is a point, this point is given, okay, this point is equal to this, that point is lying on that vector. That means we have to first calculate dw by dl. That you have, I think you have understood. dw by dl you have to calculate where dl is not dn, it is some other displacement, okay, some other displacement. It is not dw by dn, it is dw by dl. L is other displacement which is given, but we have to find out dw by dl, but at a particular point, means एक point पे देखना है. Okay. Now the thing is, gradient which was dw by dn, gradient of a scalar is a vector, isn't it? Am I audible?
Yes, sir.
Okay. So dw by dn, which was the gradient, it was a vector, isn't it? Because we have studied that gradient of a scalar gives you a vector. So this is a vector. This portion, it is a vector. It is a vector. Okay. But if you find dw by dl in the direction of this, then you are only asked to find out the magnitude. Find the direction derivative. So this is not a vector, this will be a scalar. So how to do that? Now if it is scalar, then it is okay, it will have the coordinates, but it is told, क्वेश्चन में बोला गया है कि dw by dl निकालना है, मतलब कि dw by dn जो था, n for नागपुर, मतलब शॉर्टेस्ट पाथ, वो तो हमारे पास है, लेकिन वो नहीं चाहिए, dw by dn नहीं चाहिए, dw by dl चाहिए दूसरे डायरेक्शन पे. अब वो तो चाहिए, लेकिन उसके ऊपर एक पॉइंट है, उस पॉइंट पे dw by dl का वैल्यू क्या है, दैट वी हैव टू कैलकुलेट. That is the second part of the question. So there is no problem. We can calculate, but the condition, means data which we have some missing data because we don't know dw, okay, and we don't know dl, because in gradient we know that how to calculate, because del operator we know, we are putting the scalar on the del operator, we are getting. But obviously dw by dl will not be calculated by using del operator. Why? Because dl is not the shortest path. So what we can do? We can do one thing, that we have the gradient with us, delta w. So delta w is traveling along the shortest path. Now what we will do, delta w is a vector, so it is having a magnitude and a direction. So magnitude is mod of delta w, suppose. Magnitude is mod of delta w. Okay. And direction is the shortest path. Now if you take the mod and separate it from the vector, then what we have? We have the mod with us. We have the mod with us, which is not having any direction. Now we multiply or we associate this direction. If I cover the confusion, let me use blue color. Okay. Now, since this is the direction of dl, so what we will do, we will take the mod of w and associate with the direction dl, that is unit vector l, because dl is the displacement, dl is a vector, but dl is nothing but dl and a unit vector al. Unit vector al is along the direction of dl. So this unit vector, what we will do, we will associate with this mod, so that as if the delta w is traveling along dl, because delta w along dn is gradient, but delta w along dl is not the gradient, because it is along this path. So delta w is nothing but dw by dl. So dw by dl into this dot product with this. So dot product with this will give us the value of dw by dl. anything. If you take another path like this, suppose this is dm. So if you want to find the derivative, direction derivative, so what we will do, you will take the first delta w gradient and you multiply with that vector dot product with the direction vector of dm. You will get the value of dw by dm. You can do like this. So you have to calculate this. If you calculate, you will get one value. Suppose this delta w is actually, it is not the mod because it is this value. Okay, actually not mod. I will correct myself. This is not mod because this is the vector itself. Okay, because we are shifting the vector, because vector क्या है, डेल्टा w इस डायरेक्शन पे है, तो अगर इस डायरेक्शन में निकालना है तो क्या करेंगे, डेल्टा w का मॉड ही एक्चुअली है, लेकिन उसका डॉट प्रोडक्ट अगर इसके साथ करेंगे तो उसका मॉड ही निकलेगा. तो वेक्टर तो घुमा दे रहे हैं इस डायरेक्शन में, इसलिए इसके साथ एसोसिएट करेंगे तो ये घूम जाएगा. डेल्टा w यहां नहीं रहेगा, यहां चला जाएगा. ठीक है. अब डेल्टा w इज दिस वैल्यू एंड al is a unit vector. So what is unit vector? Unit vector of this. So what is unit vector of this? Vector divided by the modulus, magnitude. Okay, so what is magnitude of this one? That is, what is magnitude of this one? Magnitude will be, I am talking about the magnitude of dl. That is, dl का magnitude क्या होगा? Root over of 3 square plus 4 square plus 12 square. 9, 16, 144. So it will be 13. Root over 169. 13 होगा. और ऊपर क्या है, ऊपर वेक्टर है. सो दिस इज इक्वल्स टू यूनिट वेक्टर L. एंड नाउ दिस gradient is equals to this. But what we will do, we will not take this value because the question is told, in the question is asked actually, that you have to find the dw by dl at a point. So what we will do, we have this point with us, this point with us, this one. So we will take this point and we will put the value on this particular delta w. So what we are getting, we will put 2 on x, minus 1 on y and 0 on z. So first one, what will we get? 2 into minus 1, that is 4. Next one, 8 minus 8, then minus 2. So this is gradient w at that particular point. So we are getting gradient w at that particular point. Now associate with the direction vector, unit vector. So this vector divided by magnitude, because unit vector, we all know that unit vector is actual vector by magnitude. So actual vector is this divided by magnitude. So this is not the correct way to write, because for saving the time it was written like this in the book, but when you write in the exam you have to write the entire thing, that is like this: 4 unit vector x minus 8y minus 8 unit vector z, dot product of this by this. So if you take the dot product, you all know, then you will get a scalar value. So this is minus 44.13, because if you take the dot product of this vector and this vector, you will get 44 and denominator will be 13. Actually you will get minus 44. Okay, now have you understood that how to find, if the question it is asked that you have to find dw by dl, where dl is not the shortest one. So what you will do, you will find first of all the value of dw by dn for the shortest path, that is gradient. Now you take that gradient and you dot product with the direction, then you will get that value of dw by dl in that direction. Any point is asked, if it is asked to calculate on a particular point, you just put the values of x, y and z. And if it is not asked, then you no need to do that. You can just calculate the in terms of x, y, z. Okay. So have you understood this problem?
Yes, sir.
Okay. So now let us go to the next one. Okay. Next topic rather. Okay, now we will discuss about the line, surface, volume integrals. Now in vectors, okay, what we do in vectors, whenever we have a particular, we can say, suppose there is a path like this, okay, path or area or volume. So what we do, we don't know the actual size, okay. So what is done, we represent, because this is the representation of physics, that why we represent in this way. So suppose the total length of the path is capital L. So we will divide this total length into very small segments, okay, and each segment is equals to d small l. Now what will be the total length? Integration of dl along the entire path, okay. So if there are 100 paths, then integration from 1 to 100, okay. So we call that line integral. Why? Because we are integrating on a particular line length, okay. We are integrating on a particular length, okay. Now if there is area, that I will show you, okay. First of all, let us concentrate on the line integral, okay. Now area means surface, so surface integral means you are integrating the small areas to calculate the total area. And similarly for volume also, the entire volume will be divided into small volumes, then you have to integrate each volume and to get the total volume of the whatever volume is not a vector, it is a scalar quantity, so you have to calculate the total volume in that way. So remember, line is actually it is a vector because it is displacement, okay. And area which is represented as surface, it is also considered to be a vector, okay. And the unit vector of a area or a surface is perpendicular to the surface. That is the you can say the direction vector, okay. The unit vector of that particular surface is perpendicular to it, and volume is a scalar. Now the line integral is the integral of the tangential component of A along curve L. That means when we have a particular area, a vector, okay. So when we have a particular vector, suppose vector A is traveling like this, okay. It is moving from left to right, okay. Now if you have a surface like displacement like this, a path, suppose the vector A is traveling from left to right and there is a point A on the vector, okay. Forget about this line, okay, just concentrate on this point. We have a point A on the vector and B on the vector also, because total is A is traveling like this, A vector, okay. There is a vector, a huge wave you can say, having direction magnitude. So from point A to point B, you have to move a particular, suppose any charge or anything. Suppose you want to travel from point A to point B, okay. Suppose you are on a river, the river is flowing from left to right, okay, and you want to cross the river on a boat. What you do, you travel from point A to point B on a boat. So what you will do, what will happen, you will get some force always on the left hand side of your boat. It will try to drag you on the right hand side. This is already we have studied in force. So what we do, we have to calculate that amount of, you can say, line integral. So we are traveling this path, okay. So what we will do, we will divide the path into small segments. Each segment length is dl, okay, and we will integrate that. That is, a line integral of a vector is meant that in this way, that you have a vector and you are traveling from one point to another point in that vector. So line integral means vector along the particular path, okay. So that is equals to a integration of a dot dl. That means you are considering each total line as each segment of dl and you are integrating, okay. It will be a dot dl. So vector a dot product dl with this integration, okay, finite in that you can say the definite integral, okay. Now, whenever you have a dot product with you, so dot product means one vector with another vector, so mod equal to mod of vector A and mod of vector A, dl multiplied by cos of the angle between them. So what is the cos of the angle? Cos of the angle will be the angle of the vector which is making with respect to the dl. At every point dl may change, okay, because whenever you are starting, suppose vector A is constant, so over here theta will be, the angle will be different, here theta is different, here theta is different, so everywhere the theta angle will change, okay, if we consider the vector here also, because here also it is existing, so here the theta angle will be different. So at every segment, how many segments you divide, for every segment you will have the different values of theta. So A value is constant, dl is also constant, so theta will change. So depending upon that you have to integrate. This is the way of representing. This is the representation of line integral of a vector. So a vector field A and a curve L, curve or length whatever, we define the integral like this, okay. That means integration from A to B, mod of A, then mod of dl, then cos theta. Now if you traveling from A to B and again returning to A, that means it is a closed contour. Closed contour means a curve which is starting and ending, because it is a complete curve. That means wherever you are starting, you are ending at the same point. So that is also a line integral, but we call it a closed line integral. So same thing, equation will be same, just you have to put a circle in between the integration sign, okay. It is called the closed line integral, okay. Now coming to the surface integral, same thing. Suppose surface is two-dimensional. Now it is similar to this, we have a same contour, but in the previous one we were only concentrating on the side, that is the length of the contour. In between there is nothing, it is empty, okay. In between there is nothing, it is empty. Now for the surface integral, what we will do, in between it is not at all empty, it is having some, the total contour is suppose made up of a certain material, okay. It can be a ferromagnetic or it can be anything, okay. It is made up of material, suppose, or a non-conductor or insulator, whatever. So it is a surface, so that means it is having some area. Now surface is also a vector, that means the total surface which we have, we call it surface, okay. The total surface which we have, we cannot find the area of the surface. So what we will do, we will divide the surface into small areas, suppose this square, okay, and we call that area of that particular small segment as ds. Now ds is also a vector, because surface is a vector. Now the direction of the vector is perpendicular to its surface. So if this is ds is the small segment area, that means a small surface or small segmented surface whose area is ds, magnitude is ds, then vector will be perpendicular to it, okay. It is perpendicular to it. Now the thing is, we will divide the total surface into small segments like this, okay, small segments. So this particular surface is not flat, it is curved, so we will get a surface like this, okay. It will be bent, it will be straight, it will be curved, whatever, but we will assume that it is divided into small segments. Now same thing, so suppose we want to find out the surface integral of the vector, that means the vector is traveling. So what is the impact of the vector on this particular surface? What is the impact of the vector on this particular surface? Okay, how can I define this? Suppose I give an example. It is in the example of flux. That means in magnetism, I think magnetism you have studied in your school levels and your diploma also, because you are from you have completed your polytechnic. So magnetism in electrical machines, I hope all of you know. Electromagnetism is there, magnetic poles are there, field is there. Okay. Now we know that fluxes are traveling from north pole to south pole in a permanent magnet. Okay. From north pole to south pole, flux flow, magnetic flux, represented by phi or psi rather, and the unit is Weber. Weber, short we write WB. Okay. Now this is called flux. Now what is flux density? Can anyone tell? What is flux density? You must be knowing.
Flux per unit area, sir.
Yes, flux per
Flux
unit.
passes per unit area.
Yes, yes. Flux per unit area means. So what is flux per unit area? That means, suppose you have a magnet, okay, a huge magnet. So the total amount of flux you cannot measure because the flux lines are concentrated as it is closer to the poles and closer to the magnet. So as it reaches, it actually diverges and it spreads out. Okay, so the gap increases. So you cannot measure the total flux. Okay, total flux you cannot measure. So what we do, we assume that we only deal about with the flux density. That means we take a small area like this and we measure the flux passing through that particular area. So measure only that flux. ये कितना फ्लक्स इस एरिया से पास कर रहा है, एरिया के बीच से पास कर रहा है. You only measure that. Okay. Suppose that flux is phi. That amount of flux which is passing through the area is phi. Okay. Now what is the area? Suppose that area is delta S. So we call that flux per area is flux density. Suppose it is B, or in this case we are writing A, flux density. Okay, it is flux density. So that means flux is equals to area into flux density. That means flux density into area. A is the flux density and ds is the area. तो मतलब flux density क्या है? Flux per unit area से कितना जा रहा है? Flux per unit area, that is flux density. So flux is flux density into area. Now we know that if you put one area over here, then you will get another value of flux density. Okay, if you put another area of here, because flux density will be same actually, because flux density is constant, because density means it is constant. But you can calculate different with respect to different areas. We will calculate different fluxes because this is flux density only for this area. What about the total area? That is integration. We call this surface integral. तो total ये जो A हमको मिला है ये constant है. This is the flux density. But flux which we are getting, this is actually d phi or d psi. The flux which you are getting is actually d psi because we are getting this flux only for this small amount of area. If you want to calculate the total flux, then the total flux will be integration of d psi. The total flux will be the integration of, it is the integration of d psi. Okay, so integration of d psi means it will be the total flux. So integration of d psi means integration of A ds. So that is why it is represented in this way. So same thing we are considering over here. This example was with respect to flux. Suppose we have any other vector, flux नहीं है, कुछ और vector है, ठीक है? So it is A. That vector is A. Suppose, okay. Because flux density is a vector. Because ये तो हमने देखा ना flux density जो है, it is actually a vector. Okay. The flux density which we are getting, it is actually a vector. So similarly, here, so vector is passing, okay, and we want to know that what amount of vector is passing through this area. Okay. Okay, so that means that vector, that means what amount of vector is passing through this area, so that parameter will be a scalar parameter. Okay, so what is the vector associated with this area? Okay, so that means the vector associated with this area will be the surface integral of that vector. Now this is having a unit vector, so whatever we will write in this way. So cos theta. Now what is this theta? Theta is what this vector is making with respect to this surface. Okay, that vector with this normal vector. That means what vector, what angle this normal vector is making with this particular vector A. So if you have a vector over here, okay, if I concentrate on this, so that unit vector will be perpendicular to it, perpendicular to the surface, but that angle may not be 90 degree with respect to the vector, because vector is having a different direction. Okay, so that angle we have to know. Now this is for a surface. Now if you take a closed surface, it is a closed surface integral. Okay, now you can say what do you mean by a closed surface? Closed surface means surface तो close ही रहता है, लेकिन नहीं, ये जो है ये ओपन सरफेस है. ओपन सरफेस मतलब मान लो इफ आई गो टू द लाइन, बिकॉज लाइन एंड सरफेस इज वेरी मच एसोसिएटेड रिलेटेड टू ईच अदर. कैसे? ये लाइन जो था एक पॉइंट से बी पॉइंट, इफ यू कम बैक टू ए पॉइंट इट इज बिकमिंग क्लोज्ड लाइन. ओके, क्लोज्ड लाइन. ओके, दैट मीन्स क्लोज्ड कॉन्टूर. we will calculate the closed line integral. Okay, so a contour which is closed is actually equals to an open surface. It is actually equals to open surface. Now closed surface का मतलब क्या है? Closed surface का मतलब है कि this part and this part should touch each other. That means a closed surface like this. ये surface है closed रहता, तो okay, so if this is closed, this touch and this part are touching, then we will get a closed surface. Okay, that is called the closed line integral, a closed surface integral. So see this line carefully. A closed path defines an open surface, whereas a closed surface defines a volume. मतलब एक path जब closed रहता है तो that is an open surface. And now if you take the surface and if you where you are starting and where you are ending, if you combine them, if you connect them, then it becomes a volume. Okay, so it becomes a volume. So closed surface is nothing but volume. Now volume का जब integral निकालते हैं, so it is not actually any with respect to a vector, because if you have a volume with you like this, okay, if you have a volume with you, so you don't know what is the total volume, suppose. So what we will do, we will divide the entire volume into small segments. Okay, and this is having volume dV. So total volume V is equals to, okay, integration. So what is this? What this is actually called the volume integral. Volume density. Okay, volume density. जो वॉल्यूम डेंसिटी कहते हैं. वॉल्यूम डेंसिटी मतलब सपोज टोटल वॉल्यूम इज इक्वल्स टू दिस. नाउ सपोज वी हैव अ स्केलर. So scalar, that scalar, suppose the scalar is scalar P. Okay, so P is a scalar quantity. Now that scalar quantity is within this particular volume. So what amount of scalar quantity is inside this volume? That is equals to P divided by small volume. Okay, that is called the volume density. Okay. Now if you want to calculate the total amount of quantity P, okay, this is actually rho V. This is called rho V. Okay, this is called rho V. So volume density means any particular quantity divided by the volume, we get the volume density. सो P इज सम पैरामीटर, सपोज स्केलर क्वांटिटी जो इसके अंदर है, ठीक है। तो क्या करेंगे, टोटल वॉल्यूम का हमको पता नहीं है, तो क्या करेंगे, छोटा हिस्सा हम निकालेंगे। तो जितना डेंसिटी बाहर होगा उतना डेंसिटी उस बॉक्स के अंदर भी होगा, क्योंकि अगर छोटा सा वॉल्यूम हम निकालते हैं तो हर जगह पे एक ही डेंसिटी होगा, ठीक है। तो दैट P is constant, so P divided by that small volume will give you the volume density in that particular part. Okay, so if you take the volume density and if you integrate with this, okay, so you will get the total value of P. Suppose इसको हम ऐसे नहीं बोल दें, एक मिनट, हाँ, suppose that means P is equals to rho V into dV, ठीक है। तो ये P है, लेकिन ये P क्या है, ये P छोटा सा P है, क्योंकि P जो है निकला है हमारे, तो इसके अंदर जो P का वैल्यू है वो सिर्फ निकला है, इसके अंदर जो P का वैल्यू है, बिकॉज वॉल्यूम वी ओनली कैलकुलेट विद रिस्पेक्ट टू अ स्केलर, ओके। सो इसके अंदर जो P है उसका वैल्यू हमने निकाला है dP, बिकॉज टोटल P जो है वो टोटल वॉल्यूम V के अंदर है, लेकिन छोटा सा हिस्सा में वी हैव ओनली dP, so this is actually dP, okay। So dP divided by dV gives you rho V, so rho V is constant. Similar to this, here also we have seen that the total density, okay, that is the vector A, flux density is constant everywhere, so multiply with surface we get the total flux, sorry, we multiply with the small surface we get the small flux, okay, only flux passing through this, okay। But if you want to calculate the total flux passing in the entire area, छोटा सा एरिया को फिर इंटीग्रेट करना है, तो तभी हमको टोटल एरिया का फ्लक्स मिलेगा। हियर ऑल्सो इन दिस पर्टिकुलर स्मॉल बॉक्स वी हैव ओनली dP, सो dP by dV वी गेट rho V, सो rho V इज कांस्टेंट। सो पूरा P निकालने के लिए क्या करेंगे, इंटीग्रेशन करेंगे, दैट इज इंटीग्रेशन ऑफ rho V dV। सो व्हाट इंटीग्रल, वॉल्यूम इंटीग्रल। तो वॉल्यूम इंटीग्रल का मतलब है 3 डायरेक्शन में, क्योंकि लाइन इंटीग्रल जो होता है वो ऐसा होता है, ठीक है, लाइन इंटीग्रल, बट सरफेस इंटीग्रल जो होता है वो 2 डायरेक्शन में होता है, एक्स एक्सिस देन वाई एक्सिस, ठीक है। अगर वॉल्यूम इंटीग्रल निकालना है तो एक्स एक्सिस, वाई एक्सिस, जेड एक्सिस, दिस इज इक्वल्स टू इंटीग्रेशन ऑफ, दिस इज इक्वल्स टू वॉल्यूम इंटीग्रल। तो ये जो इंटीग्रेशन है ना, सरफेस एस लिखा है, एस का मतलब है 2 एक्सिस का लाइन इंटीग्रल, क्योंकि लाइन इंटीग्रल एक ही एक्सिस पे होता है, लेकिन सरफेस इंटीग्रल 2 एक्सिस पे होता है, डबल इंटीग्रल। एंड वॉल्यूम इंटीग्रल इज ए ट्रिपल इंटीग्रल ऑन द 3 एक्सिस, ओके। सो दिस वाज रिगार्डिंग द सरफेस लाइन इंटीग्रल, सरफेस इंटीग्रल एंड वॉल्यूम इंटीग्रल। So have you understood? So I am ending my lecture over here, okay. I think tomorrow also we have a class, so in tomorrow we will concentrate on this divergence, because I will not take too much time for divergence. I have taken too much time over here because I thought that line integrals, surface integral was very important to understand. If you are able to understand this properly, then the rest of the portion you won't take too much time. It will be very easy, because everywhere you will see line integral, surface integral, तो ये समझने में ज्यादा टाइम नहीं लगेगा, ठीक है। Okay, so is it okay?
Yes, sir.
Okay. Okay, so then thank you then. We can again continue tomorrow. Okay, thank you.
Thank you, sir.
Thank you, sir.